Hey guys, today I'm going to show a demonstration about probability. Probability is very complicated subject, you know that, but we can make it easy by showing some examples. Like today I'm going to show an example about how to study Bayes theorem. You know Bayes theorem, that's very complicated one. We used to like before the exam is like what's gonna do, I'm gonna forget about it. But it's very easy if you know the conditional probability. You will get it very easy. Let me show an example for you. Now, suppose A and B are two mutually exclusive events. Now, what do you know about mutually exclusive events? It means that probability of A intersection B is always 0. That means that A and B together they cannot happen. That's the point of mutual exclusive events. If I say that A and B together are mutually exhaustive events, exclusive and exhaustive events, if that what I say, and you have to know this term, right? And exhaustive events. Then you have to know that probability of A union B is always 1. That means there is only two events, there is only two partitions of the sample space. We can say that they are mutually exclusive because intersection B is null, because they doesn't exist, and what remains is the two partitions only. It's like consider this rectangle. It's like two partitions. One part is A and the other part is B. So these two completes the whole rectangle. So that's why if I consider these two A union B, it's a complete set. That means the probability of happening A and B to A and B minus A and B, or either A or either B. That means the union, right? So that's always a one. That's a sure event. Now you have to take this thing very seriously. So that's why I'm defining this terminology. Now I have to clear this. Okay. Now let's again give a little bit note about conditional probability, which is what. So let's talk about how about we have to find the probability of two events which are correlated with each other or not. Suppose that today is raining, and what's the probability of a car in accident? Like in a rainy days, like that probability of accidents is very high rather than in as opposed to the normal days. So if we so that's kind of thing is a very tricky thing, and we're going to find out. Like B is an event demonstrating that the weather is the day is very rainy, and suppose A is the event that today is the event of having an accident. So we have to find these kind of events, like today is very rainy, and what's the probability of having an accident. So that's kind of thing put mathematicians into a very troubling thoughts, and that's why the conditional probability theorem has been occurred. So let me show you some example. What conditional probability is that we have a box full of chocolates. Some of them are red one, some of them are green one, and some of them are red one and green one together. I'm just talking about the wrapper color. Okay, say there are thousands of chocolates. Chocolates, no. So toffees, and some of them are red ones. I have only red markers, so you have to imagine that. Some of them are green ones also, and some of them are both. And like there's a partition. This one is red one, and that white part you can. It's okay. White part it's the green one. Just for an example. So you have to find if I collect a red one, what's the probability of it could be also a green one? Now, that's the tricky part. All we have to do is to find these numbers of things, like how many of them are red and green all together. We will find the number of it, say A, number of A, and how many of them are only red. Let's say red. So cardinality. Let's say B, and how many of them are green. Let's say number of. Is C. Now obviously in some some B, in those B's there is some A, and in those C's there is some A too. So that's why if we find that the number of the number of red and green together is A, and the number of red chocolates is B, and the number of green chocolates is C. So the ratio of number of red chocolates and green chocolates is, and ratio of, as I said, so, and the number of red chocolate would be considered as probability of G given R. That means, simply put, that the number of red chocolates are there. I have collected the number of red chocolates. How many of them could be green? That's the point of view. I mean, we have collected number of red chocolates, and among them, a proportion we are finding, which is number of red and number of green. So that's how we find the probability of green chocolates, given that the chocolates are already red. So that's, I guess you got the idea in gist. It could be like B, and the numerator would be A. That's how it's done. Now, let's say, if you got the idea, I think you can simply put like this, that A and B are two events, and probability of A given B is always B, probability of A intersection B is divided by probability of B. As I've said earlier, it would be number of A given B by number of B, but if we divide this both ratio, divide both terms with the number of total elements, number of S, you can easily show that this is probability of A intersection B whole divided by probability of B. That's how it's done. So that's how I directly wrote this down.